to just apply.
Yes,
And
okay.
if you're able to express yourself at the interview, they will not care about the 8 years.
Okay. Thank you so much for that advice.
You will.
I'll do that.
All right. So during the last time that we met, or rather the video that I sent you guys, we did a deployment to EKS, and we also did we're gonna do the ArgoCD. So what I would do is I'll just go ahead and rerun it. Reason is I always shut them down because I don't want to keep it running. So I'm just gonna quickly build a cluster. Then we will deploy the once the cluster is built, we will deploy our ArgoCD. So as it does that, I will duplicate this. Then we'll just look at the code here real quick. So have you guys followed through up to where we are?
No, sir.
Okay, yeah. The thing is, it will be important to know exactly what is going on, so that everything does make sense. So by the end of after the session today, I'm gonna create a repo and send you guys all these codes so that you're able to clone it and run it. But it is just important that you practice, apart from just watching the video, that you actually practice and see exactly what is going on so that everything does make sense. So we did have our modules here. For EKS, we are on version 3.23 right now. And one of the things that we had last time was there was a question of how do we get users authenticated with a cluster. So once we create it, remember I mentioned that the credentials that create the cluster, those are the credentials that are authorized because they are mapped in the kube AWS auth config map, right? Config map. How do we tell that when you create an EKS cluster as a resource, right? As a resource, EKS cluster, if you go to that as a resource and you look at what are the options that are mounted within the cluster, we have this what we call access config. Right here it says bootstrap cluster creator admin permissions is set to true. But if you go to the arguments down here, access config, that it just says whether or not to bootstrap the access config values to the cluster. So it always defaults to true. So what this basically means is that is the credentials that create the cluster, they are automatically bootstrapped, right? They're automatically bootstrapped. And those are the creator, cluster creator, admin permission. It is automatically bootstrapped into the cluster. Now it is bootstrapped into the cluster, though it is not added to the config map. So it is not a configuration that you can map in the config map, but it's bootstrapped within the cluster. So, and it's mapped to a group called system masters group. So that is a group that by default has already been created or established in EKS. So now because of that, we did realize that if we are creating our cluster in a pipeline, then whatever credentials that were used to create that particular cluster, if we do not have access to those same credentials, then we will not be able to log inside of our cluster. Why? Because if we are using a role, we know that once we have that particular role, or if it's short-lived credentials, then once our runner exits, we do not have access to those credentials. So for us to do that in EKS, that's why we're creating a role and mapping that role. So for us to be able to create a role, if we look at our EKS report, let me duplicate this. Let me go to EKS. All these things I'm just doing them as a summary because we had gone over summary. So for EKS, so what we did was we created a user. We created a user that we called admin, an admin user. We created a group called masters. We gave them a policy, and that particular policy, we created a role for them, right? We created a role that they can assume. So our manager is able to assume the role. No, these are the EKS master role. Created these policies for the master to be able to assume. And there's a role that we created, a role called masters, EKS role. This is the role that the master will be using. So we are creating this and mapping it in the config map, right? Now, how are we mapping it in the config map? We are creating an AWS auth config map. And for this config map, you can actually create a resource called Kubernetes config map. The metadata, that is the name, and the namespace, skip system, right? So we are creating that. And then for the data that we are putting inside of that config map, we are passing it inside of this local auth config map data, which is this local config map data. So we are mapping roles. We are also mapping users. We can also map accounts. Now, for the roles that we are mapping, it is a YAML. We are passing a YAML as a role, but we are concatenating multiple roles. If we have a role for an admin, a role for a developer, a role for a user, we can map them all together. So we are using a function. We are using these functions, and where those roles we are concatenating any roles in the variables, auth roles, and var map roles. So we can add multiple roles here. So it will just concatenate all all of the roles. If we have users, we can map them like that. So if we look at our inputs, where we have our auth roles, this is the default that we are passing, which is just a list, right? We're passing it as a list. Now, for this is the role that creates the nodes. This is what we had seen in the config now. This is the role that creates the nodes, right? This is how is the user is that, and the groups are always system, bootstrappers, and system nodes. So this is the role that normally creates the nodes. And then we also have a role. We also have map roles, this. Okay. So we are also passing these variables as map roles. We want to concatenate this role with this role because they are all roles that we are mapping. So with this role, right now default, we have left it empty because we want to pass it at runtime because we don't want to bake it into the module. So a user can pass their own role, right? Can pass their own role by passing the role ARN if there's a username and if there's any group they want to pass. So we are leaving it as default and empty, but we will pass it at runtime. Okay. So that is how we are mapping those roles, and we are using this cube config map as a resource to be able to create it. Okay, to be able to create it. Now, one thing you have to realize that when you're using now creating this as a resource, because you want to bootstrap it, you have to create both the config map itself and the Kubernetes config map data, right? This is what manages the data that you put here. So you have to create this config map and also put the same thing, but this depends on that config map. So this is what will manage the data. It's called map v1 data. And then another thing that you have to pay attention to is when now you are creating a resource, the config map, a resource, it has to be created. You have to create it before you create your nodes. So the order is create your cluster. Once your cluster has been created, then the second thing is you have to create the config map. That is once your master has been created, then create the config map before you create your nodes. Now, if you create the cluster and then create the nodes, then create the config map, it is going to fail, right? Because you cannot create your configuration map after the nodes have already joined the cluster. So that is the order that you need to remember. So that's why you will have to pass explicit dependencies that this resource here, I'm saying it depends on the cluster. Now I have the cluster and I have the nodes. So it just means that when I'm creating this, I have my EKS and I have my nodes. This is my node group. So I have to say my node group depends on that config map. Depends on the config map. So what does happen is that now when I'm going to create to create my cluster. So the cluster, which is the node master, will be created first. Then after that, I have to create the config map second. Then after the config map, then I can create the node. Why? Because within the config map, I'm mapping the role that actually creates the nodes. So that config map needs to exist within the master, okay? Within the master, because otherwise the cluster will create its own default config map. And now when you go after the nodes have joined the cluster, and now when the resource for the config map starts creating, it will give an error because you will have a duplicate resource. Why? Because the config map will already exist in the cluster, because that is a default setting, okay? So that is something that you have to pay attention. So we had to pass this dependency such that after we create our cluster right here, then we using a null resource to provision. Then the next thing is it is going to create our config map. After the config map is created, then our nodes can now create, right? After it has completed creating our config map, then our nodes can now create. So now it will use the config map that we have created, right? The config map that we have created. So that is one thing that you just have to pay attention to. I'll also send you some things that you guys can read on how we did all this. But what we're doing that we're just mapping a user, an admin user to that role. Now, when we go now to our build repo, as I said, we are now adding roles. We are mapping roles. We have an admin. We can map users. We can map accounts, right? And we also have a kube config name, because we are running this in a pipeline for me to be able to access that cluster, within the pipeline. To run scripts, I'll need a kube config file. I need a kube config file if I'm running any kubectl commands. If I'm running kubectl commands to do an apply, then I'll need a kube config file. So if I look at my user auth, so again, I'm using this to create a kube config file. I have a locals here called kube config file. I'm checking if the cluster is being created. If yes, then I'm going to use a template file. And the template file is in a directory called scripts, and it's just called kubeconfig tpl. And the values within that are gonna go inside of that template are the kubeconfig name, the endpoint of your cluster, the base64 auth, that is the certificate, then the command to authenticate, right? The command to authenticate within the cluster. So so if you're creating the cluster, and then we use that. Now, if not, then leave it empty. Okay, leave it empty. So then where we are creating that particular cluster is we are using this resource called a local file. We will create a local file, which is our kube config file within the runner, because that's a local file. Everything is happening within the local file, so that if I need to run any kube config, or rather kubectl, if I need to run any kubectl commands within the runner, like if I have a script, then I'll have a local file that is the kubeconfig file of that particular of the particular cluster. Yeah. So that's that's why we have this right here. Now if I go to my my scripts, that's a directory called scripts. I have this kubeconfig template file. So that is your template for the kubeconfig file. And it's a template because it has variables. It has variables like the server endpoint. It will be returned as a variable. The cluster auth will be returned as a variable. The kubeconfig name will be returned as a variable. Okay. The cluster context. So all these are variables within YAML, right? Then it is running a script here for I in the command, right? It is basically running this particular script to generate for you your config file. So this is a template file. This is a template file. So with that, and what it's doing is it is going to use the local exec, local and null resource, to use a local exec to just run and see if it can get the endpoint, endpoint of the cluster. Once it gets the endpoint of the cluster, then it can go ahead and create this kube config file within the cluster. And if you have any, again, as I said, if you have any kubectl commands that you want to run, you need to have that. All right, so if we look at variables that we are passing here, additional variables, kubeconfig name, I'm giving it empty. Config path, it is in the present working directory. That's where the the kubeconfig file will be. Right, we're cluster, waiting for the cluster certificate endpoint. So it is running that long command just to check whether the cluster is up and running. Okay. So that's what it's doing. So we have a successful cluster created. We have a config map created. We have our users mapped, right? So when we go to our build repo where we're deploying our cluster, then again in EKS, when you look at your inputs, the inputs here, again, you're passing those map roles. Here, you're leaving it empty as default. Everything is empty, users, no users. But when we go to a specific .tf file, then this is the role that we are mapping. We're actually mapping two roles. We're mapping two roles, but this is just a test role. Okay, that's just a test role. So in this test role, the role that we are interested in is this role for our master. The master, we have mapped it inside of that config file. So because we've mapped it there, so if I go on to my command line right now, and I do kubectl get pods. So obviously it is going to tell me invalid because I haven't I haven't logged into that. So if I do kubectl get nodes, there's an error, right? It's an error. I basically can't log into that cluster. But now let me try and update. Let me try and update. Do AWS EKS update kubeconfig dash region US West 1, then dash cluster dash name is dev cluster. So if I just update it that way, it has updated. Now, if I do kubectl get nodes, right? Again, I'm not authenticated. I'm not authorized. Why? Because there is no mapping. There is no mapping yet to my cluster, to the config map. But because I created a user called admin, there's a user called admin, and there's a role that I created. And this role has already been mapped within my config map. So all I have to do is, let me go to AWS. So the only thing that you now have to do is go to AWS. Once you sign into AWS, go to IAM, go to where your users are. You will see a user called admin. So for this particular user admin, go to security credentials and just create an access key for them, right? Once I create an access key, I call it EKS access. I'm gonna create that key. Then all I have to do is come right here and do AWS configure dash profile. Let me configure profile called admin. Then I just copy this or paste there. Now copy my secret key and I'll paste there. So once I paste, right, I'll leave everything as that. Then I will do AWS configure this name. Then I'll use the profile dash profile equals to admin. Okay, profile is admin. Now it has updated. So once I do kubectl get nodes, okay, now you see I have now been authenticated. Right? I've now been authenticated to my cluster. How did I do it? Because I created a user, and this user has already been mapped. I already mapped the role that this user can assume. It's already mapped in the kubeconfig file, in the config file. So now with that, I have been able to authenticate just by updating my kubeconfig file. I've been using my profile as admin, and this admin has already been mapped in the system masters group. So they are a cluster admin. Okay. So if I go in here and then I say kubectl get config map AWS auth namespace kube system dash o YAML. So I'm able to see that this is the first map role that was mapped, the role that that created the nodes, EKS node group. So that is the role that we passed in within our module. Then these are the roles. This is the role that we just mapped using our config map. And then I also said we also mapped an additional role for a developer. So if you have a developer, you can give them minimal permissions. With the minimal permissions that you give, you can map them to this role. So they only need to create their access key, secret and access key. Once they have that created, then this role has already been set up. So they can just assume the role just the same way as I've done for admin. It is only that there are groups. You may have a group called developer within the cluster. And for this group, you'll have to create a role and a role binding based on the permissions that you're giving them. So create a group and bind it to a certain role within that. But if they're in the system masters, then that is an admin. Okay. Now we did it this way so that if, let's say, I don't want this role anymore, I don't want this role, or I need to change permission. Changing permission just means going to AWS or going to my Terraform code where I created the role and just modifying the permission. But if I don't want this role, again, then all that I have to do is that come right here, because this is a list. So I can come right here and I can remove this role, this developer role, okay? This developer role, because it's a map. So I can do that. I can remove that role and I can leave it as it is, right? Can leave it as it is. So once I do that, I can commit my changes. Once I commit my changes, now what I'm passing inside of my cluster is just one role. So then I'll go to my build repo, I'll go to my workflow, and I'll go to my release. So once in my release, I can plan it. To see what is going to happen. So when I run the plan, when I run this particular plan, let's see what it's going to do. So I already have my configuration mapped. I already have my cluster created. Okay, so it is going to initialize. And now we see here it plans to change one. So what it's changing, obviously, the cube config. This is the cube config file that it generated. But now here we see it plans to modify the data. This is what manages this v1 data. It manages your config file. So when you make changes, we are making changes in this data. Terraform will make changes in this data, but then ultimately this will end up in the config config file. Okay, so what I'm doing is that now I'm removing the developer role. Okay, developer role within my data, Kubernetes config map data. Then this will propagate into the config map itself. Okay, so with that, now I can go ahead and modify my config map by running an apply, checking the box. I can run the apply.
Prof, I have a question. Yeah, so you were talking about the creator of the cluster, the creator of the cluster, the right that the creator of the cluster have, and the right that the admin has. I mean, what's the difference? And I didn't see that there was any type of policy, like AWS policy that was added to the admin, or is it just something that just gets inherited automatically?
No, the policy for the admin, as I was showing you, is we created a user. This is an admin policy,
Oh, okay.
assume the role. And we had on all resources, all actions, right? All
Mhm.
actions. But this is AWS permission.
Yeah.
They can do anything in AWS. But as I had mentioned before, you can be an admin in AWS, but not necessarily an admin in EKS, right? So for this admin, we created them to be an admin in AWS, but also an admin in EKS. The
Okay.
fact that the permission in EKS, as long as they're in the system masters group, that is an admin group in EKS. Okay.
Okay.
So I could easily have said the resources is just EKS. I can give them all actions on EKS. It just means that this admin, they are only responsible for EKS to manage EKS. They are EKS admins, my cluster admins. But once they come to EKS, then they're in the system masters group. But for testing purposes, we just gave them admin permission in AWS, because this is an IAM policy for AWS, right? And they are able to pass any role to that particular service. So and that particular user, as we say, they are able to assume the role. Anybody in the account, right? They are able to assume the role, but also we passed this specific role that we created, this master ZKS role. This is the role that we mapped in the config map.
Yeah.
Okay. So they are able to assume that role. As long as they can assume this role, then this role has already been mapped in our config map. It has already been mapped in our config map passed here.
Yeah, but your admin, for example, now your admin now, you that created the cluster, the permission that you have, because we're talking about bootstrapping the creator's identity on the cluster. Is it different from this admin
Yes,
cluster? Yeah.
it's different from this admin. Why? Because one, we don't have control over that admin's credentials,
Yeah.
like the creator of the cluster. We don't have what do you call it? We don't have control over that because it is bootstrapped within the cluster, but it's not mounted in the config map.
Okay.
So that is a default setting. So now we want to make sure that the users that are doing administration work on the cluster, that that we have control over them. So how do we have control over that? We have control over them by actually mounting them in the config map, because now we can limit the permissions that they have based on the role, right? Based on the role that we have. So now once we have this mapped in our cluster, and the cluster has been created, then now what we do is that we create a group of admins, people that will be managing the cluster, and we just add them to the system masters group.
Okay.
So for that, we have control over who is doing what, right? We have control over who is doing what, and we know who are actually in that particular group.
Okay.
So this is just how management of users is done within the cluster.
So these people the people that are part of this admin now, would they be able to destroy the cluster? the people that are part of this admin, would they be able to destroy the cluster?
Yes,
Would they-
as long as you're in the system masters group, you're a cluster admin.
Okay.
Yeah.
Okay. Thank you, sir.
Yep. All right. So we've gone ahead and updated our role. So because we've updated our role, now if I rerun the same command, we've updated our config map. Now we see that we remove that role. So we're able to modify our config map. So this is a better way or an easier way to do it, other than you having to every time to log into the cluster to edit and knowing what permissions, the permissions that you have. You need to have to be an admin who is capable of editing the config map before EKS allows you to do that. So a better way to do it is, if you're using Terraform, then again, just create your AWS auth config map and mount roles as we've seen. Now we have our cluster now created. So let's now go ahead and deploy our ArgoCD. So for ArgoCD, I can go back again here. For ArgoCD, go back to, actually I need to be here, go back to our code. Let me move this out of the way. For ArgoCD, so let's go to our modules. So the second thing we'll deploy is our ArgoCD. When you look at our ArgoCD, we have our main. We are in version 1.202. Yeah. So the change that I made here was, once we deploy ArgoCD, we know that we need to create what we call applications. You guys know what applications are, right? We all know what applications are.
I mean, is that the what is created in the manifest with the manifest?
No, an application is a configuration. You have to configure ArgoCD by creating an application. Creating an application is what you are telling ArgoCD, track this, like track this particular, hold on 1 second, like track a particular cluster or a particular repo. Let me pull it up here. So if you have something like this, you can have an application. An application is something like this. Okay. An application is something like that, whereby you have a name, which repo ArgoCD will track, right? And the destination and the sync policy, right? So this is what we call an application. So we want to make sure that users are able to create their application and pass their applications during runtime, because once ArgoCD is deployed, maybe tomorrow you have a new repo, you want to deploy a new image, a new project. So all that you have to do is you have to create an application for it. Once you create an application, you're telling ArgoCD, this is the repo that we would like to track. This is the repo URL that we would like to track. And the destination is within what namespace are you deploying it, right? So this is what we call an application. Then also for every application, because of the repo, there are secrets. You have to deploy a secret, right? A secret for that particular repo, right? So because of this, when we created our module, when we created our ArgoCD module, so again, let me go to ArgoCD module. When we go to ArgoCD repo, when we deploy this module, we had our provider, we had our main, and our main, we just had a namespace. Then we had, after the namespace, we were deploying our ArgoCD itself. Then we are creating a service, okay? But what I added is a resource for the application and a resource for the secret, right? And this secret, we are using some documents. When we go to now data, that's a cluster auth, that's the namespace, data that will create our namespace. This is the data that will create our ArgoCD itself. And this is the data that will create a service, because we need to expose ArgoCD. So it's going to create a service for that. But we also have a data, and now here, this is not a file, this is a path for documents, because you can have multiple documents within that path. So, and the pattern here, when you look at Terraform, how it gives you, if you're using this, you will use a pattern, because you can have multiple files. So what kind of files do you want to be part of this document list? So I'm passing it as a variable, so that, and also the secret, so that we can pass them at runtime. It can read this variable at runtime, okay? So with that, if I go to my inputs, so I added this application, that's just a variable. Then the secret, that's also a variable. I didn't pass any default, so I made this required, so that when we are calling the module, we can pass those, right? And then obviously this local, those are the local block for our provider. And then the only manifest that I now have here is the install for ArgoCD, the namespace, and the service. So these are the only things that we are baking into our module. And now when we come to a build repo, where we are calling the module, remember those three variables? These are the three variables that the cluster expects, that the module expects: cluster name, var for application, and secret. If I go here, those are the inputs that, again, we are passing them. But the var for the application, I'm passing a default, okay? Because it's a pattern, I'm passing a default. I have a directory called application. So from here, from this modules directory where we are, go back 2 steps and go into a directory called applications. And in there, any file using wildcard, any YAML file, because remember, this is a pattern. So we are saying any YAML file within that directory, then it is supposed to be considered as the part of the algo, right? Then for the secret, the same thing. I have a directory called secrets, and now any YAML file in that directory will be considered as part of the pattern. Okay.
Yeah, Prof, please, I have a question.
Mm-hmm.
So in the context of like when you have like multiple like application, I mean, when I mean like application, like okay, you have like your we're using, I think we're using Datadog, right? We're trying to use Datadog to kind of observe those applications.
Mm-hmm.
I think that's a goal, right?
Yeah.
Okay, so if we're I mean, so the Datadog is just observing just the cluster, right? It's just a cluster that is observing.
Okay, hold on to that. We are going to deploy it and we will see exactly what we've been looking at.
Oh, okay, okay.
Yeah, we're going to deploy it right now. Right. So we have our ArgoCD here, and again we'll just deploy it in the dev environment. So when we get to a dev, that is just our cluster, and for ArgoCD, our variables will be the same because we don't want to. We will just deploy whether it is in the development environment, in the prod environment, or staging environment. We want to use the same ArgoCD. We just create applications for dev, because we want to have a central place where we can monitor. That is the same thing with Datadog, right? We want Datadog to monitor all environments. We don't want to have, because we're just using one account, we don't want to have one Datadog instance for prod, another Datadog instance for dev. So our variable file dev will be the same, right? Will be the same in our case right here. Okay. So with this, again, modules. So within ArgoCD, as I said, or within the build repo rather, I have a directory called applications. So we were in modules, we're in ArgoCD. So one step back is in modules, another step back, and then go to applications. So once you go to your applications directory, there are some YAML files. So these are now your application sets, right? I can have these application sets for my Helm. I can have these applications set for my manifest, right? And that is the repo that those manifests are in. I have a YAML or a Helm, right? Helm chart, that is the repo that these Helm charts are in. So I have this manifest for my applications. Then I also have secrets. I have secrets here and secrets there, right? So now with that, I can now go to my actions and do a release. At first, let me plan it and go here. Now I want to release ArgoCD. Okay, I want to release ArgoCD. Let me plan it first in the development environment. Once I do that, it is going to start running. Initialize the backend. Okay. To create those applications because it has found the cluster. So it is going to create it. So the plan is good. So let's go to release and let's release it. So let's go to ArgoCD. Let's check the box. Not do a release. So it's going to install ArgoCD within our cluster. And because we have already created applications, so once it creates it, it will create the applications too. Okay, it will create our 3 applications that we have. Then so let me be here. It's creating that. So it has applied and and finished. So the apply is complete, has added 61 resources. So once it has done that, then we'll go to a terminal right here, right? And let me just split this into two. And we split it into two like that. And what I'm gonna do is we now have to port forward, right? We have to port forward. So if I go in here, because I'm still the admin, if I do kubectl get service dash namespace, we created a namespace called ArgoCD. Right. Then we will see that we have this is the service that we are interested in. This is a service that we created, an ArgoCD service of type port, right? And we want to port forward this port 443. Then it will forward it to our node port, So we want to port forward this. So the command that we're going to use is kubectl port forward our service ArgoCD. Let me just copy it here. So we will do like that. We port forward a service so that we can access it. We'll forward it to maybe port 8080, and we are within the cluster. We want this port, right, in the namespace ArgoCD. So once we do that, we are able to port forward it. Now, once we've port forwarded that, then we can now go to our browser, localhost on port 8080. Okay, port 8080. So once we go on port 8080, did I type the right thing? The local hosts 80. Enter. So click on advanced and proceed to localhost and set. Okay. So once you go here, it is going to log into ArgoCD. Yeah. Once you're logged into ArgoCD, again, the username is admin, and then the password, we have to get the password. How do we get the password? We have to leave this port forwarding, and because we are using a local host, but otherwise you can create a node port service with a load balancer service, and use the DNS for that to access it. But for us, we are using a local host. So if you look on the documentation, there's a command they give. So we'll just copy that command. We'll copy that command to get our password. Right, so we'll paste it here. That is the command, kubectl get secret database. There's a secret called ArgoCD initial admin secret. So once we enter, it's going to return for us the secret. And I copy that secret, go here and paste the secret. Once I paste sign in, once I sign into ArgoCD, I will see that ArgoCD has already configured my 3 applications. Okay. My 3 applications have already been configured, and these applications are healthy. Now I look at this first one, it has 2 pods that are running, right? 2 pods that are running. I go back to my applications and I look at my tests. They are unhealthy. The pods are, it's a Helm chart, they're unhealthy. And I look at the other application, my ArgoCD application. I have 2 pods that are running, okay? 2 pods that are running. So now for this, now we can now use ArgoCD to monitor everything within our cluster. Now let's say tomorrow my boss asks me and they say, okay, can you create an application? Can you create another application? Right. So what I will do is that I'll come to my build repo. I'll come to my build repo. Maybe we have a new image. We have a new application that we want to go. So I'll come to my build repo and all my applications live here. Okay, they'll all live here. So I'll come here. Then let's say I want to create another application like this. For now, I'll just copy this, duplicate it. I'll go back to my applications. Then I'll add a file, create a file, and I'll call this file my other app. As long as that is a .yaml file, as long as it's a YAML file, because everything was wildcard, then .yaml. Then let me paste that application here. Then I can use the same application. I can change the name here as my other app. That's the name of the application. Then maybe I want it in which namespace? I want it in my other, a namespace called other. Okay, a namespace called other. So this is there's a ticket that came in and I was asked, can you create we have a new application that we want to deploy. So can you create a new deployment? So all I have to do is that come into my application and just create an application referencing the repo. Which repo am I creating this? Are we building this application? So I'll come right here. I'll create my application. Once I create my application like that, create my application, the namespace that I've been told, and that is the repo that is going to be there. I've passed the secret right now because I'm using the same repo. So the secret has already been deployed, right? But also you can find a way of making the secret so that we don't pass the secret as a file, but making the secret available within the build repo, so that all those secrets will just be passed at runtime. So now once I've created this application, all I need to do is just commit the changes. Okay, commit the changes. Now I have my other app. Okay, so right now I only have three applications that have been deployed. But now, because I've created another app, all you have to do is now come to my release. Come and just do a release. Okay, do a release. So go to, I want to release again ArgoCD. ArgoCD, I can plan it first. So when I plan to see what changes are going to happen. So once I plan it, let me see, it is going to get all the credentials, set up the backend. All right, set up the backend. Then it's going to look at if there is any change in ArgoCD. You're going to run that plan because it's using the state file, but then it's going to see that there is an application that is to be added. So now for this application, and this is the YAML body of the application. It's being created in a namespace. That's the namespace called other. Okay. So now with this, once I'm satisfied with the plan, then I can release it. So I'll go back to my release, go back to my release, then I'll release ArgoCD. I'll check the box and I'm gonna release it. So with this, once I release it, so within ArgoCD, it will create the application. So Terraform will Terraform will create the application. It'll create the application for us within ArgoCD. Right, so let's see. Project plans. Let's gonna run the plan. And it's gonna do the apply. So once it does the apply, then we see it has just created my other app, which is healthy, and now it's running. Okay, so ArgoCD is able to monitor that. So we have our module, but all our applications, we are passing them at runtime. So as developers or as engineers, they can just be directed to, if you want to do any deployment is, now this is where now you, as an engineer, once you've created the pipeline, then now you do documentation. You create an SOP on how to do deployments in Kubernetes. All you have to do is you're doing documentation and you're telling your group, all you have to do is go to the build repo, create your application and put your application in the applications directory. Okay. So that is an SOP that you're creating. Put your application in the applications directory and run the pipeline, run the release pipeline. So once you do that, the pipeline is going to to test if there are any tests that it is going to do, but ultimately it is going now to deploy your application. And you can see your application, your application now created within ArgoCD. So you can create as many applications because ArgoCD relies on these applications to track different repositories. Okay. Now, if your boss asks you, okay, we no longer need that application, so we no longer need that application. So can you just go and remove it? Okay. So first, if I go to, let me go to my terminal here. If I now do kubectl get namespaces, then I'll see I have a namespace called other, right? A namespace called other. If I do kubectl get pods namespace other, I have these two pods running because it's part of a deployment. So I have these two pods running. So I can go and scale up. We all know how ArgoCD works. So I can go to my repository where my manifests are, and I can scale up, right? I can scale up that. Now, if I come here and try to edit, if I do kubectl get deployments, in that namespace, I have a deployment called demo. So if I come here and try to edit it within the cluster, I do kubectl edit deployment demo in namespace other, right? Namespace other, and I say I want 10 replicas. I want 10 replicas. I want 10 replicas and try to ten replicas. Ten replicas and try to save it. So try to save it. Where was it? I was looking at that. Okay, if I go back to my edit, I see I have 2 replicas, but I just edited them 10. So let me try it again so that we see. If I go here and I say I want 10 replicas, and immediately I do that, I've edited the deployment, but once I go back to check it again, I see that it's just 2. So what happens is that this is the self-healing capability of that ArgoCD brings. When we created our application, our application and looked at our applications here, there is self-heal. It's true. The self-heal is true. So it just means that I cannot do anything in the cluster. The only source of truth is if I do it from here, the repo. This is the repo that's doing. So if I go to modify something in the cluster, it will self-heal. It will compare it with this, and it's only the this particular repo that is the source of truth. So that's the self-healing capability. But now we also have the prune. Prune means if I modify something in the repo, then it should do what? It should prune it from the cluster. It should modify it within the cluster. So now I can do what my boss can tell me, oh, we no longer need that my app. So what we do? I go here, that my app, and I can delete it. So once I commit my changes, I've deleted that my app from that particular application. Or I could go to that particular repository and modify or remove a manifest for a service or a manifest for a pod, right? So once I do that, then again, because that's my build repo, I need to run my pipeline. So go here. If I plan ArgoCD, if I plan it, I'll see that my release is gonna realize that I no longer need that application because it's not in the configuration, though it's in the state file. So it will try to remove it from the state file. So that application will be removed. Right? It will be destroyed. So with that, I can go to my release, go here, go to my ArgoCD and release it. Yeah, release it. Once I do the release here, do the release there. The release, then it is going to remove it. Yeah. Okay, so that application has been removed from our ArgoCD. Okay, so again, this is we already know how ArgoCD works on the repo, so I'm just showing you how we are deploying it for now. So that's the application. Again, the order we deployed our class VPC, then our cluster. Now we've deployed ArgoCD. We could have deployed our Datadog first, but it doesn't matter. Our Datadog will still pick up ArgoCD. So let's go back to our code and now let's do a release on Datadog. So again, if we go to code, your modules, we have our Datadog module. We have our provider, same thing. We know that our main, we are passing a Datadog API keys, all this, our site inputs as variables, all these things, we pass them as variables. Then our data, we need to read the cluster. Why? Because we are deploying a Helm chart within the cluster. So Datadog is not only monitoring our cluster and what is in the cluster, but it's also, we are also creating an AWS integration. So it monitors everything, all our applications, all our infrastructure in AWS, but it's also monitoring our cluster. So if we look at our Datadog module that we created, Datadog module, created a module for Datadog here. So we had variables. These are variables that we've seen. We created I created teams. Again, these are, you can have different teams with different roles in Datadog. Providers, we need a kubectl provider and we need a Datadog provider. If we don't pass, because these are specific providers, if you don't pass this provider within the module, when you call it, because the first thing Terraform always does is try to initialize modules. So, but for the providers, if you don't pass this specific provider, it will try to download the source being HashiCorp kubectl, and it will not find it, so it will fail. If you don't pass Datadog on the module here and leave it so that you are passing it when you are calling it, what will happen is that it will try to download HashiCorp Datadog, because the source for everything is always HashiCorp. So if the source is different, if you have any other source apart from HashiCorp, then you have to tie it to the module where you're creating the module, so that when the module is called, it will download the appropriate providers. Okay, so that's why we pass this this right here. We can create monitors, and these are things that I think we had looked at. Monitors just for our dashboard. Then for Kubernetes, we are creating a namespace. We're just creating a namespace here called demo. This is the namespace that that we want to deploy our Datadog. We are using Helm to deploy our Datadog. So we have a Datadog agent that we will deploy within the cluster. We have a Datadog dashboard. We'll create a dashboard. Then just for data, these are the permissions that Datadog needs in AWS for us to do the integration. Okay. We're creating a role for Datadog integration. Then this is our integration. We are integrating it with AWS, right? The account ID, we're using a data source to get the current account. Then the role, ARN, this is the role that we are creating that Datadog will use for the integration. So if I go to Datadog, or let me do it here. If I go to Datadog, no. Oh, look at infrastructure. No, it's still caching this. Kubernetes. There's no data in Kubernetes. Datadog, it still caches. It stores your information for a couple of days before it lets go forth, because these are trial versions. So it will keep all your metrics and your information and your logs for a couple of days before it lets go, right? But right now we don't have any logs, right? We don't have any logs. We don't have any Kubernetes. So that's our Datadog. So let's go and deploy it. I had run it before, but now let me go ahead and deploy it. If you look at our dashboard, we basically don't have let me see, our custom demo service. We don't have any Kubernetes pods or anything running there. Yeah. So what we'll do now is I'll go to my build repo. I go to my build repo here. Then I'll go to my actions. Once I get to my actions, I'll go to my release and let me look at Datadog. Let me try to plan it. Try to plan it. It's going to run. Initialize it to pull the module. It says it's clean, right? Because it is reading a state file, and it shows that where I had deleted the cluster before I deleted Datadog, before I destroyed Datadog. So it already has a state file, but now it's reading it and saying, okay, everything is up to date, but it's not up to date. So let me go and do a release on Datadog. So I'll do that, do a release on Datadog and check that and run. This. The credentials, get the module. Original, it plans to add to the namespace and that Helm chart, using the Helm chart to deploy inside of the cluster. So this is the part that we're interested to deploy in the cluster. but the other integration is happening outside of the cluster, which means it is deploying it in AWS. It's configuring Datadog, creating the integration. So if we look at infrastructure, or we look at, where is it? We look at integrations. So we will see that it is going to create it has created for us this AWS integration. That is a role that it's using. Yeah, the role that it's using. So it has deployed for us that Datadog. It has deployed for us and it's done. So if I come to now my infrastructure here, now I see that it is pulling. These are my two nodes within the cluster. It has my load balancers within my cluster, or rather within AWS. All this is AWS. These are my two instances that are running my cluster. So it has pulled that up. If I look at my host map, it pulls in US West 1C and US West C. So I can look at, these are my nodes. These are my nodes. Those are the labels. It gives you information about that. So if I look at my my Kubernetes overview, because I deployed an agent within the cluster, then again, it is showing me that I have 12 deployments. I have 2 nodes. I have 25 pods, 37 containers, 18 replica sets, and that. If I look at my pods, then it is still showing me the state of my pods, right? The state of my pod. This is the cluster name and which namespace, the namespace that it's that it's running. I have my other namespace. I have these 2 pods. I can look at the pods. It gives me the state, right? The quality of service, the replica set, the IP address. So it basically gives me everything I need to know. It is showing that the step ready is true. You can look at the YAML manifest for that particular pod, right? YAML manifest for the pod. You can look at all the metrics. If we had configured them, you can look at the processes network. If all these have been configured, you can look at the logs. Right now, no logs have been found, right? So that is, you can explore this. You can explore namespaces. These are the namespaces that we have within our cluster. Now, Datadog is using the agent that we deployed in the cluster. So it is returning all these metrics. That is the name of the cluster. That is the status, right? And these are the pods in every namespace, right? Pods in every namespace. Then look at your workload, deployments. Those are your deployments. Do you have any jobs? No. Any cron jobs? No. Daemon sets. You have these daemon sets. So you have your Datadog agent. You have AWS node in the kube system, and you have your kube proxy. These are deployed as daemon sets. You have any stateful sets. You have your ArgoCD controller as one stateful set. Okay, so that's Kubernetes. Now that is now part of the infrastructure. So you can look at different structures, your host map, your containers. That's to do with Kubernetes. You can look at network performance if we had configured that, network devices. So it gives you everything. You can look at your cloud cost. It is gonna show you if you've configured this, it will show you what the cost is, the cost for running everything in the cloud based on the resources that you have, right? But then you can look at logs, you can explore logs. This is where you as an engineer, you probably spend most of your time looking at. So you look at logs as they come in, and when you look at the keys here, this is just for information, this warning, this error. So if you have pods that are failing, if there's an issue, then it will come in as an error. So I can filter that and see what errors I have within my pod. So if I look at that, I see I'm returning the cluster agent error. Okay. Or let's say that I go to one of my, we have our ArgoCD repo. When my dev ArgoCD Helm, it's healthy. Or ArgoCD, when my dev ArgoCD manifest. So let's say I went to this organization where my dev repositories, where my manifests are, ArgoCD manifest. I went to this prod and I went to my YAML file here. On this YAML file, let's say I had a typo. I say Nginx 1. We know that image doesn't exist. Okay. So I commit changes. That's my deployment. I commit my changes in that. Then I'll just go to ArgoCD and sync my applications. Okay, so I want to sync. Let me just sync all applications. Okay, so obviously once I sync the applications, I'll see that this application, right, will go into error because that doesn't exist. So if I go here, and I look at my pods, I just look at the errors right here. So let me do it the other way. ArgoCD might not deploy it. So let me do this. Let me do this. Let me do kubectl. kubectl run. Let me create a pod called Nginx, called Nginx1 dash image equals to Nginx1, right? Nginx1. So let me run that. Pod is created. Kubectl and get pods. I see Nginx1, but I have an image pull error. Have an image pull error. So once I go to ArgoCD, or rather to Nginx, to Datadog, so ArgoCD here, I was trying to reconcile. I did that. Updated successfully. All this is ArgoCD. Line service. Okay. It's taking a while to pull it in. But also what I can do, I can go to my container map and go to my pods, and I can look at my my pod that I just created 1 minute ago, Nginx1 image back off. I can go to investigate. There's an error occurred. The tool cannot run this pod. The latest manifest is covered. So you can look at that. Okay. Okay, and it's not giving me logs now, but what it's doing is status, it's waiting because it backed off. Waiting because it backed off. So we can see it here. So we have visibility inside of our cluster. It's showing us right here, it backed off. Let me see if those logs have come in. I can explore logs. Oh, this is just information. Information. Okay. What about namespaces? It is all here. Namespaces. Default. The default namespace, I have four pods that are in error. In my app, I have one that is in error. Shows me what they are. In that namespace, I have four that are backed off. They show me which one is it, which one was backed off. We have all these that have backed off from the deployment and from that Nginx. Yeah. So it basically gives you all this visibility into your cluster. Visibility into the cluster. I needed to see these logs. Yeah. So you can configure. There's so much you can do with Datadog. You can configure so that it tracks issues. You can create alerts into PagerDuty. You can create log streams, pipeline where it will stream or forward logs to specific, maybe an S3 bucket, right? But if you're just exploring, again, you can just look at it here. So it's supposed to pull everything in all namespaces. Mm. You just have a stream of logs. Yeah. That's a live trail. Mm. Yes. Supposed to have a fail, an error. That's Nginx. Yeah, so you guys can you can explore around all through these logs, and let's explore your way around through the infra. Let us explore. So it's a quick way to give you visibility into what is going on. You can look at specific logs, and you can go and basically configure that. I can go back to my Nginx. I can do ctr get pods. get pods in the next one. Dash driver dash drive dash one equals to points dash YAML. And I can use some minutes. Dash drive dash one. Yeah, it's here. Help, you can always use help on this find. No, I'm doing the wrong thing. I'm doing the wrong thing. I shouldn't be doing this. I'm doing this. Okay. No, Nginx. I can come here to the image and correct that image. Right. And Control X. And I can do kubectl apply or replace. Yes, this is plus. Yes. Nginx. Java. Once I do that, so I can fix that. So this will be cached for a while, because that's what Datadog does. It doesn't just drop your logs or information, because sometimes you need to investigate. So that's why your pod will be running, but it will still cache your logs or your information. So you will can look at this. I don't know why it's not pulling that instantly. Let me look at logs. Let me filter it by remove ArgoCD. Remove agents. Agents. I see in the next. Okay. Agents. Okay. And we look at the host. The two hosts, source Regional cluster status and Kubernetes namespace. Which is namespace is demo. It's only pulling from it's only pulling from the demo namespace. I'm pulling from namespace is demo. The pods. Those are the Datadog. Machine. So this is the namespace that we deployed our Datadog within the cluster, but it's returning all. If you look at the container map, it's returning all containers in all namespaces. Where do I have my Nginx? Let's see, agents. The Nginx. That's our Nginx. That's our container Nginx. You can look at all the information about that particular container. Again, you can easily go to the overview, and you can look at your pods, and within the pods now we can see Nginx. It's running because we modified it, but we still have a record of it so that we can investigate, right? And investigate, right? What is the dashboard for the pod that is running? You can look at the different dashboards that are there, right? So this is this is basically what's Datadog, what Datadog does, and we have deployed our ArgoCD that is monitoring our infrastructure. We changed. So right now, as you see, until this one becomes healthy, it will not terminate the previous deployment. So that's why, because it uses rolling update, it is until this becomes healthy, that's when it will start terminating. But otherwise, the users will still access this access that particular application. Yeah, that particular application. So, and if you try to synchronize all applications, basically that is out. Okay. So that's it. We've looked at our release cycle. We've been able to look at EKS, Argo, Datadog. So now the next thing that that is left that I'm probably gonna do a video is now Docker. So we'll have to do a release for Docker, to on a release for Docker, we'll need to have a Docker file, which you already have here. So we'll put a Docker file in there and be able to do a release. Right now, what our workflow is doing, it is just building the Docker file and pushing it to Artifactory. So, but while in Artifactory, we need now to pull it and deploy, pull it and pull the image and now deploy. And again, for that particular image, it will be as easy as going to our ArgoCD repositories and just updating the image. But once we do update, then our workflow needs to be able to pull that image from Artifactory. Once it pulls the image from Artifactory, it is able to do it, to deploy it in our cluster. So that is the only part again that is left for this. So I'm going to send you guys a short video on how we pull the image and deploy it to Artifactory. So again, that image will have to be containerized first. Once we have the image containerized, the image has been built, it has been pushed to Artifactory, it has been versioned. Then now, once we do a release, once we know that we have a new image in Artifactory, then we can do a release. Right now, we might be running on version 1.0, but maybe we have a version 1.1 out. So we will just go up and do a release. But we'll also put multiple Docker files, and build in a logic so that depending on the application that we want to release, you might have multiple images for different applications. So we're going to build that logic within our Docker, how we pull the particular image, and also just the logic on how we build particular images, because you might have 2 or 3 Docker files. Okay, so that is a video that I'll send you guys. Okay, you guys have any questions?
Yeah, Prof, I have one question. Please, I want to know the difference between Datadog and Prometheus and Grafana. I mean, do they do the same thing in the cluster in terms of visibility?
Yeah, it's basically all a monitoring tool, right?
Yeah.
It is doing the same thing just to monitor, but when we use Prometheus and Grafana, then we are deploying it within the cluster. And it is only, depending on how we are installing it, it is only monitoring just our cluster. But the advantage that Datadog again brings is we have a lot of other integrations. So
Yes.
it is not only just monitoring our cluster, it is monitoring our entire infrastructure. Our entire infrastructure. If we look at our host map, these are our instances themselves, right? These are our instances themselves. That's that's our Linux running on Kubernetes. It's in AWS,
Yeah.
right? It is showing you the metrics of that particular instance. If you have any containers on it, so it's showing you the metrics of the containers, showing you showing you Kubernetes, what version of Kubernetes and what the CPU and all that. So it is monitoring the state of the instance itself, because
Yeah.
we've done a configuration with AWS. Now, right now, if I go to AWS, let's see, if I go to AWS, so right now I only have these two, right? I only have these two instances. So if I go to AWS, let me see AWS console, and I go to EC2, and I launch an instance. My server is Ubuntu. Just launch an instance. I don't want to keep here. And I leave everything as default. And I go to launch an instance. Just will launch an instance. Now if I go to Datadog and refresh it after a while, I'm going to see let's see. So after a while, it is going to pull in that instance. Going to pull in that instance. Right now, you still have this one, two. I'm going to zone.
So basically, Prof, what you're saying is that the data dog is just watching everything that's going on in the account.
Yeah. So it's just watching to see, because again we have that integration, Datadog integration. Let's see, we have this. We created this. This is the integration. Okay. So for that particular integration that we created, you're passing in the account, then the role that it's using, those permission that it has, metrics collected, enable, so it's collecting all metrics. We can pass it if we have any filters or tags or host tags. Again, we can pass them. So like if I created that instance and I passed a tag as Ansible Ubuntu, right? Then it can also use those to pull them in. So if I go to my, if it hasn't pulled it yet, So let me see if I go to my instances, my server right here. I do Ansible. What's that days? Ansible hyphen v2. Those are the tags. Okay, and then in a couple minutes, it's supposed to pull it in. Yeah, I think that's it. And that's the one. And that's the one. Post info. Name is Ansible.2. Name is my server. So if you look at the ID DF38, DF38. Yeah. Look at tags. Tags is Ansible Ubuntu. So so because of that, it has now pulled it in here. Then look at the host dashboard. So it is giving you some metrics, right? Your process is free. Nothing is running on it. Nothing is running on it. So this is looking at infrastructure, container, hosts, availability zones. So it's gonna pull it in shortly. All right, so basically basically that's it. When we look at the hosts, you look at the hosts, it has now 7 hosts which are now being monitored. It is getting metrics from them. It's just because we haven't configured anything on this host,
Okay.
so we can't collect any metrics because nothing is running on it. So this is just the reason why Datadog is becoming popular, because I can do much more with this than me just setting up Prometheus and Grafana to do it, to watch my cluster. I can get much more metrics in the cluster, logs and everything using Datadog. But it is now not just that. It becomes cost effective because I can monitor other things. It is pulling in my load balancers. If there is an issue with this, with the right configuration, I can be able to look at my logs. Once you configure it correctly, you can look at all these traces, security agents. So all these, you're looking at all the applications, everything that you have in your AWS account. You're able to have a single place where you can do this. And not only that, you can now configure integrations. And apart from integration, you can log stream. You can create a log stream whereby you can forward your logs. You can forward your logs to a different, right? You can forward your logs. You can configure log forwarding, right? You can either archive or a custom destination. You can log forward. You can forward your logs to maybe an S3 bucket or something like that. So that's why most companies now are going with Datadog, as just because of what it offers.
Okay. Yeah, because there was an interview that I had that they were saying that they have Prometheus and Grafana at the same time they had Datadog. So I'm like, I know that Datadog can do the same thing and even more. So I'm kind of wondering why they have both Prometheus and Grafana and Datadog at the same time.
Yeah, hi. I don't know why they used both, but maybe Prometheus and Grafana, maybe they had configured it as legacy. It was there as a legacy application, so
Yeah.
it has still been working. So they just can just take it, unless now they use Datadog monitor their Prometheus and Grafana too, because Prometheus and Grafana, remember, it's all deployed in the cluster. It's running within the cluster. So if something happens within the cluster, something happens with the cluster, then you don't have visibility. But as you see, Datadog is a standalone. It is an software as a service that we've configured. It's outside of the cluster. We're just deploying an agent in the cluster, right? But it's looking, and beside that, it has log retention. So if we do it, even if our logs like something happens within the cluster, because these are free account, I think the retention for the logs is about, I think it's 1 hour, and then they let go. But you can configure this so that it retains information for as long as 3 months, as long as 4 months, so that if something happens within the cluster, you will always have that information for you to do it, for you to do a post-mortem, to find out what really happened. So it's capturing logs in real time, and then it retains them so that you can do a post-mortem to find out what really happened, right? As opposed to when a system crashes and then everything is gone. Unless you are directly streaming your logs somewhere else, right?
Yeah.
Okay, so with this, I'll just go ahead and as I said, I'll make another video of how we deploy deploy now our images. But for right now, I'll just go ahead and delete. So I'll go to release. I'll just do it the reverse so that I keep the state file clean. I'll go to my Datadog and I will destroy. Run or destroy. And as you see, even if I run or destroy Datadog, it will not immediately destroy what is going on in Datadog. Right. I don't think it will. It will keep this for some time. It will destroy the integration. And all that. So that has been destroyed. Let me see the integration. The integration has been destroyed. And I look at infrastructure, my host map. My host map is still there. That's my instance. That's my the instance. When I look at my Kubernetes overview, it's still showing me that I have these 2 pods. I have these pods. It's still showing me that they're still up and running, right? So I can, if something accidentally happened within the cluster like that, I can still have access to my to my logs, right? I can still have access to my logs. I get to my logs. I still have access to to the logs within the cluster, though I have destroyed it. Destruction is complete for that Datadog agent. So it has log retention, right? It will not just immediately delete everything. Okay. So, but if you go to ArgoCD now is different. If I go to ArgoCD and go to release, and I go to ArgoCD, and I do a destroy. I run that. I go to my release. To my release. I do a release. Yeah, we just destroy them. Now that's gone. That's gone. Once I refresh it, I can't reach it anymore. So that's gone. You can see it is gone. And again, the logs here. The logs here, they still show the agent, they still show ArgoCD. Still show that. Then I'll go back here. Oh. Now I'll get to my AKS cluster. Let's run destroy. Right, so when you're doing that, so obviously this connection is lost. Obviously the connection is lost. So when you're doing that, if you go to cat AWS config. So make sure you just create this profile. Create that profile in there because you'll always use the same role. So whatever role that you're creating, just map that role in there. So then all that you do is that once that particular user, that's why I'll just keep with the profile admin so that when I go to set AWS configure, AWS configure -- profile admin, I don't have to go to the config file to again do this, right? Map the role. So map the role in there with your source profile as admin. So the only thing you'll be doing is just adding the credentials, adding the access key in the credentials file. Then those are the credentials that will be used to assume that role. Yeah, to assume the role. And so this is what they will tell you at work is unless you have SSO, which works differently, they will just tell you, go into AWS. Your boss will send you this role. They will just say that we have a role, or because you have an access to AWS, they will say that they have a role called master EKS role. So you have a master EKS role. Just assume that role and you'll be able to have access to the cluster. So now you need to know what to do. So what they are saying is, first, if you are a user within that particular, in AWS, then generate your access key or your secret and access key. Once you generate those keys, do AWS configure and create your admin profile, create your profile. but under the profile, put the role that you've been told. That's the role ARN. And your source profile will be the particular profile that you configure. So once you have this, then you will update your kubeconfig file with the profile that you just set. So once you do that, then you will have access to EKS. All right. So generally, that's what will happen at work. There will be a group that has been created for admins or for DevOps, and that group, there's a role that they can assume. So just configure it on your end, assume the role, and you'll be good to go.
Yeah, Prof. So how are we going to get this? Because you know that without us setting up this thing in our system and testing it by ourselves, we're not really going to, get our head around it very well, So how do we get this the code so we can set it up in our own system and do what you're doing?
Yeah, so again, as I did mention at the beginning, I said, once we are done with this, because we have all these iterations, I'm going to create a repo, and I'm gonna send you guys all the code that you can clone and replace it with your own values. So I'll create a repo and I'll send to you guys. Right?
Okay.
But by now you already have most of the code. You have an idea of what is going on, but just with the changes to different iterations to make it do what we want it to do. So that will be the only addition, but you'll have the code.
Okay, sir. Thank you very much, sir.
All right. All right. If we don't have any other questions, let's call it a day. So I'll have to get to work in a couple of minutes.